Erica Bickford.
Erica Bickford. Erica Bickford from the Department of Energy for Storage and Transportation is going to basically give us a brief, or I don't know how brief. She is going to give us a presentation on nuclear storage. So can you hear me?
Yes, I can. Can you hear me?
Yes, you can. Perfect. It works. So
all right. Hi, everyone.
Hi. We are here as you are the expert here, and we are going to yield the floor to you, and you can give your presentation. And if you would entertain questions from us afterwards, that'd be fantastic.
Yes, absolutely.
Perfect. Well, the floor is yours.
Okay, I'm gonna pull up my slides and hopefully this works seamlessly. We had a Windows update last night, so it's always a chance that things go awry. All right. Can you see my screen?
Yeah. Yes.
All right. Oh, first of all, thanks so much for the invitation to speak with you all tonight. Appreciate it. I'm Erica Bickford. I'm Director of the Office of Storage and Transportation and the Office of Spent Fuel and High-Level Waste Disposition at the U.S. Department of Energy, and I'm joining you from Washington, D.C. I understand you all had some questions on the safety of spent nuclear fuel storage and transportation, so I have a short presentation and very happy to take questions afterwards. All right. So starting with the basics, what is spent nuclear fuel? First key thing to understand is it is a solid. I know there's lots of Hollywood movies and cartoons, including Ninja Turtles, that I grew up watching, that would maybe portray radioactive material as a glowing green ooze. But when we're talking about spent nuclear fuel from nuclear power production, it is a solid. It is actually on your screen on the graphic on the left. It shows a couple of the different things. One is the nuclear fuel pellets. So it's about the size of a jelly bean. And the pellets are made out of a uranium ceramic. So that's the actual nuclear fuel. And then those pellets are stacked up inside a metal tube, and that tube is called cladding. And many tubes are bundled together into what's called a fuel assembly. So that's the picture on the far left, and that's about a 16 by 16 grid of those tubes. That is a single fuel assembly. That fuel goes into a nuclear reactor, and pictured on the top right, the blue, shows what the inside of a nuclear reactor that's loaded with nuclear fuel. So this is fresh fuel when it goes into the reactor. Once it's inside the reactor is operated to produce fission, which creates heat, boils water, generates steam, turns a turbine, produces electricity. After the fuel has been in the reactor for a period of time, going up to 2 years at this point, it's no longer efficiently generating heat, and so it's considered spent. And so the spent fuel is moved out of the reactor and placed into storage. And then if you haven't seen one, pictured in the lower right is what a nuclear power plant looks like. On the right is the kind of classic from The Simpsons cooling tower, the hourglass-shaped concrete structure. In the middle, the concrete cylindrical building is the reactor building at this particular plant, but different plants have different looking reactor building. So that's what we're talking about when we're talking about nuclear fuel and spent nuclear fuel. In the US, we have currently 94 operating commercial reactors. These are all light water reactors. So the fuel I'm showing you is called light water reactor fuel. All of the nuclear power plants in the US are light water reactors. Other countries use different types, notably Canada has something called a CANDU reactor. That stands for Canadian Deuterium. They have fuel that looks different than ours because it's a different design. But by and large, most of the nuclear power plants operating in the world today are light water reactors, including in the US. So we have reactors at 94 sites that are still operating, or 94 reactors at 54 nuclear power plant sites in 28 states. 20 plants have shut down, and about 95,000 metric tons of spent nuclear fuel has been produced to date. If all of the currently operating nuclear reactors continue operating throughout their likely extended lifetime, which is about 80 years, then we estimate that we'll eventually have about 180,000 metric tons of spent nuclear fuel. So we have the most. We have the most reactors in the US and we have the most spent nuclear fuel. And that does not include any new reactors that we may build in the future. You can see on this map, most of the nuclear power plants are concentrated in the eastern US and Midwest, with a couple on the West Coast. And how it's stored. So when fuel comes out of the reactor, it goes into a fuel pool, and I have a picture of that next. And then it's stored in, after the fuel pools start to fill up, the fuel gets moved out into what's called dry cask storage. And so this shows a diagram of the fuel. Again, remember it's a fuel pellet that is assembled into a fuel rod, and fuel rods are bundled together into a fuel assembly. And then the fuel assemblies are placed into, in this model, this is a canistered system. So there's a stainless steel canister that multiple fuel bundles are placed into, anywhere from like 20 to 35 about. And then that stainless steel canister is welded closed and placed inside a concrete and steel overpack. And that is stored outside. And that concrete and steel provides shielding, and the stainless steel canister contains all the spent nuclear fuel inside it. When we talk about transporting spent nuclear fuel, in this system, you take the canister outside of that concrete and steel overpack, and you place it in something called a transportation cask, which is a specially designed container for transporting spent nuclear fuel. The graphic on the right shows a diagram of what a transportation cask for spent nuclear fuel looks like. They're generally steel and lead to have lots of shielding for the radioactivity coming from the spent nuclear fuel. And that canister slides inside of that transportation cask. There are impact limiters that go on either end that kind of provide cushion for the cask in the event of an accident. And then in this case, this is loaded on top of a rail car. And there's some equipment attaching it to the rail car. There's a cradle in the middle that holds the cask onto the rail car. This model has end stops at either end to hold the cask in place. There's different designs that are used for different types of casks. Some of them have other attachment mechanisms, but this just shows one example of a common design. On this slide, I have some pictures of spent nuclear fuel in storage. So on the top left, when the nuclear fuel comes out of the reactor, it goes into a fuel pool. And this photo shows a fuel assembly either being loaded in or pulled out of a fuel pool. So it's a pool of water. And those assemblies go into that pool, and they typically stay in there for a period of about 5 years before they're moved into dry storage. It can be shorter, it can be longer. A lot of it just depends on sort of the operational needs of the nuclear power plants. When the fuel is moved into dry storage, it's placed into a canister. On the top middle photo, this is what a stainless steel canister. Inside is what's called a basket, which are basically slots for each fuel assembly to be slid into. So each of those squares inside that canister will hold a fuel assembly. And the fuel assemblies are about 12 to 14 feet long. So these are large containers. And then there's a couple different types of storage systems. So here on this screen, I show you 3 different types of canistered systems. So this is where you have that stainless steel canister loaded with assemblies of spent nuclear fuel. And then in the top right is what's called a vertical concrete cask system. So that canister goes inside that vertical concrete cask system, and it's stored above ground and outside. This particular storage pad is at the 3 Mile Island Nuclear Generating Station in Pennsylvania. There's another design in the lower left that is below grade storage. This location is at the San Onofre nuclear power plant in Southern California. In this case, they built up, they filled in and made kind of a little hill. And then they built the storage system so that those canisters would go down into concrete overpacks, but the same idea with the canistered system. And then in the lower middle is what's called horizontal storage modules. So again, you have these concrete and steel bunkers essentially. And in this case, the canister is stored horizontally instead of vertically. And you just turn it on its side and slide it in and then put a cover plate on top of it. So those are the current types of storage systems that are used at nuclear power plants all around the country. I think a lot of the systems used today are these canistered systems. There were earlier on in spent fuel storage, which started in the 1980s, 1986 was when the first nuclear power plant started to load spent nuclear fuel into dry storage. Earlier systems were dual purpose systems, also known as bolted lid or bare fuel systems. And instead of having a separate canister and separate storage overpack with a separate transportation cask, it was kind of a all-in-one. You have one container that was made out of steel and lead, and you put the spent nuclear fuel in it. It could be stored in that container, and it can be transported in that container. Those types of systems are less commonly used today, generally probably because they're more expensive than the canistered systems. But I have a photo here on the lower right. These are those types of bolted lid or bare fuel systems from the early days of the dry storage technology. These are all out at the Idaho National Laboratory in eastern Idaho. And moving on to transportation of spent nuclear fuel. So this picture here on the left is a picture of spent nuclear fuel in transport in the US. This was a shipment that occurred around 2003 that went from the West Valley facility in New York, which was a one-time reprocessing facility that never really operated, but had some commercial spent nuclear fuel. So the Department of Energy got involved in the decommissioning of that site. And there was about 2 containers of spent nuclear fuel that they ended up shipping from New York out to the Idaho National Lab in eastern Idaho. And this is what it looked like in transport. You can see it's that was one of the bolted lid systems, and so it has impact limiters on either end. There are rods connecting the impact limiters at each end. The blue thing in the middle is the cradle holding it to the rail car.
It's a little different than that, but.
And is there a question?
No,
Nope, sorry. We're
No worries.
gossiping, or not gossiping. What do you call it? We're just
talking about the graph.
discussing stuff
Okay.
over here about your graphics.
Okay. So this was from an actual transport. So in the US, we do have experience transporting spent nuclear fuel. We haven't done it a lot at this scale. It's been done a handful of times with commercial spent nuclear fuel, so nuclear power spent nuclear fuel. The US Navy, of course, has nuclear powered submarines and aircraft carriers, and they've been transporting their own spent nuclear fuel for more than 65 years at this point. So the US does have quite a bit of experience with transportation of spent nuclear fuel overall, but hasn't at this time transported very much commercial spent nuclear fuel from nuclear power plants. Usually it's smaller research quantities, smaller containers. But in the future, when we have federal storage and disposal facilities, we expect to be transporting more regularly, and it'll look something like what you see on this screen. And in this image, this was, I believe, around Indiana or Illinois when the state was doing a radiological inspection of the shipment as it went on its way. And so these packages that are used for transportation, whether they're the canistered systems or the type B or the bolted lid systems, typically have to meet a pretty high threshold for their design. So for the packages that my program is planning to use to transport commercial spent nuclear fuel, we'll be using transportation containers that are certified by the U.S. Nuclear Regulatory Commission. And the requirements for those packages, which are specifically in transportation parlance, are type B packages. And they have to be designed to withstand a number of accident conditions that represent sort of the types of forces that the cask could see in a transportation incident. So here the graphic on the right shows first it has to be able to survive an impact, which here is in a free drop onto in sort of its most damaging orientation where a corner of the cask hits first. Next is a puncture, so it falls on like a spike. then a fully engulfing fire at 800 degrees Celsius or 1475 degrees Fahrenheit for 30 minutes. And then finally, immersion in water. And a single package has to be able to survive all 4 of those first tests on the same package in order to meet those requirements. And so those tests are intended to represent sort of what's the worst type of transportation accident this package could see, which is, you know, a collision, falls on a bar, there's a fire from some fuel source, and then it rolls off, you know, a cliff into a river or something like that is the concept. And then still that container, that package would contain all of the radiological material. And then for spent nuclear fuel type B packages specifically, there's some additional water immersion tests that are required at more depth. So these are pretty much the most robust containers used to transport any material in the world. And these are international standards. So the US Nuclear Regulatory Commission and the US Department of Transportation conform to the international standards for these types of packages. So where spent nuclear fuel is transported around the world, you know, whether it's France or the UK or Japan or somewhere else, they're using the same type of packages that meet the same standards. I did want to highlight for you that the Department of Energy, in addition to preparing, you know, transportation and, you know, siting facilities for storage and eventual disposal of this material, we do also do some research on the safety of spent nuclear fuel storage. And we have one project I wanted to share that's looking at the safety of what's called high burnup spent nuclear fuel and storage that will also involve some transportation. So higher burnup spent nuclear fuel, that just means that the fuel stays in the reactor longer to produce more electricity than earlier eras in the nuclear industry. So today, pretty much all of the spent nuclear fuel is considered higher burnup. And in order to put this fuel into storage, data is needed to provide to the regulator, demonstrating that the fuel condition conforms with the package that you're placing it in, that the fuel is not going to have any breakdown in it. It's going to stay intact. And so starting in 2013, the department collaborated with the nuclear industry through the Electric Power Research Institute. That's the entity that the nuclear power plant industry uses to conduct their research, to load a cask of spent nuclear fuel at the Northampton Nuclear Power Plant in Virginia. It has a specially designed lid that allows instrumentation to be inside the cask. And it's had temperature inside the cask monitored since it was loaded in 2017. And so it has about 9 years of data been collected so far. And the data collected so far supports the safety of the spent nuclear fuel. There were some concerns that the temperatures inside the cask could get above a certain point that could cause the fuel to break down. Those temperatures were never observed in the measurements that we have. So that's great news for future storage of spent nuclear fuel by the Department of Energy and current storage of spent nuclear fuel by nuclear power plants around the country. But to close out this research project, we need to open the cask up, take some of the fuel rods out, and take a closer look at them. And you can't do that at a nuclear power plant. They don't have the right facilities for that. But you can do it at the Department of Energy's national labs. So we're going to be transporting this cask of spent nuclear fuel from Virginia to a DOE national lab to continue that research and development on it. And we announced just about a month ago, the department reached an agreement with the state of Idaho to allow that cask of spent nuclear fuel to be transported to the Idaho National Lab. And that transport is planned to happen in 2027. And we'll be using the Department of Energy's Atlas rail car, which is pictured here on the right, to do that transport. This is a specially designed rail car specifically for transporting spent nuclear fuel and high-level radioactive waste. Pictured here is the rail car on its final test run. It took about 10 years and $30 million to develop this rail car and qualify it to the Association of American Railroads standard for rail cars used to transport radioactive material. It's very similar to the design that the US Navy uses for their spent nuclear fuel transport. Pictured on this cask right now, that's not a spent nuclear fuel cask, that's test weights It has not transported spent nuclear fuel yet. The first shipment of spent nuclear fuel it does will be in that 2027, but to do the testing of the rail car and qualify it, we used weights that simulate the weight of a package of spent nuclear fuel. And so I wanted to share this with you all because the expected transportation route of this shipment of spent nuclear fuel is likely to go through southern Wyoming. So it'll be coming to your neck of the woods. And I wanted to make you aware of this and offer to provide additional information as needed. The Department of Energy is coordinating with states and tribes along the transportation route, including with staff from the Wyoming Office of Homeland Security, to coordinate technical assistance, to offer emergency response training, and other information for the shipment. And for this particular cask on the right-hand side of your screen, I just have a rendering of what that cask will look like in transport. It does have those end stops at the end. It has impact limiters. It has an additional personnel barrier that's going across the middle and over the top. And that will be loaded on a rail car. And it weighs about 180 tons. And so that's why we'll be transporting by rail, because that's a weight that's very doable by rail, but pretty heavy to move across the country by road. And then I just wanted to wrap up with some information resources. And I did share my slides as well, so you can get a copy of them. For additional information on storage and transportation of spent nuclear fuel, I included links to these 2 Nuclear Regulatory Commission booklets that are great information resources. They're pretty short, about 10 to 15 pages, and have lots of good pictures in them. If you want to take a deeper dive, my office has done a historical review of the safety record of transporting spent nuclear fuel in the US and internationally. That's about a 100-page report, so that's more detailed and technical. You can find that report on our Curie website that's linked here. You can find more reports for our program and fact sheets, as well as project information, including on that high burnup research cask shipment. We have a project page there listed. So I will leave that there and invite any questions you have.
Wow. Thank you. Erica, those links, can you send those over to our town clerk and we can post that on the website?
Yes.
Perfect. That would be awesome if you could. That way people can look and see and read for themselves and get acquainted with all the information.
Yeah, absolutely. I sent them to Callista.
Okay, perfect. You already
That's
got
the
them.
right person.
I haven't seen them yet, but I'm sure.
Okay,
I sent them right
perfect.
before the meeting, so you might not have seen them.
Right on. You guys are ahead of me then, so that's awesome. Does council have any questions?
I have nothing intelligent to ask this. I would like to read more of what she sent over, but that's great information. Thank you. Yeah. How often are you seeing transportation of nuclear waste right now? You mentioned commercial.
Sure. So when we say nuclear waste is a little bit of a tricky term, just because it's kind of used more generally. In the field, we refer to more specifically low-level waste, sometimes intermediate level waste, or high level waste. So there are shipments of low level waste going on all the time, from decommissioning nuclear power plants, Department of Energy's Office of Environmental Management decommissioning facilities around the country from the Cold War era and the Manhattan Project era, and things like that. In terms of spent nuclear fuel, or the higher level, what would be kind of fall under the umbrella of higher level radioactive waste, that's less common. It's really occurring in those research quantities, which is, sometimes one assembly or a couple of fuel pins. For our program, we last transported spent nuclear fuel as part of that high burnup research cask project when the fuel was initially loaded back in 2017. There are research reactors at universities around the country that periodically need to move the spent nuclear fuel out of their fuel pools. Some of those shipments are going to be starting up again soon. And that fuel goes to Idaho National Lab for the most part. Some of it has gone to the Savannah River site down in South Carolina. So for the research reactors and commercial reactors, occasionally, for the Navy's shipments of spent nuclear fuel, at least annually, and sometimes many times a year. It kind of depends on what their cycle of decommissioning or refueling submarines and aircraft carriers is.
Well, thank you.
Cool. I actually do. I have a question, and maybe you may not have the answer to this, and that's okay. I suppose you probably do. You seem like you're incredibly intelligent, so smarter than me at least.
Oh no, now you're putting me on the spot.
But we had multiple residents ask about what happens to bar none if, well, this is kind of a multi-part question. What happens if one of these casks actually does have a leak? What is the danger to our town? So just to give you an idea, where they're going to be storing this fuel is roughly about 3/4 of a mile to a mile north of town.
Okay.
And so what danger would it present? Let's say one of these casks, I don't know, a meteor hits it and breaks it open, right? I don't know.
Mhm.
Okay, that's a wild theory there, but whatever. Just it breaks open. What is the danger to bar none?
So that's really going to depend on what is inside it. But I will say that there has never been a transportation incident involving spent nuclear fuel that caused injury or harm due to the radiological nature. None of these packages have ever been breached in accidents. So if you got hit with a meteorite, I think the danger is probably more from the meteorite than the package of spent nuclear fuel.
Okay,
But
maybe that was
again,
a bad
it
example.
depends on the specifics of what's inside it.
You wonder about
And
it.
what's there. And we do have lots of plans in place. The department has lots of emergency response capabilities through the National Response Framework. There is a nuclear and radiological annex to it that has a whole host of federal response capabilities for radiological incidents. So in the very unlikely event that there was some kind of transportation incident or meteorite or what have you that caused a release of radioactive material, there would be a lot of federal resources brought to bear to contain the situation and remediate it the best way possible, depending on the circumstances.
You're going to make me famous or infamous for my meteorite comment.
Yeah, that is not the first time I've had a question about a meteorite, believe it or not.
Well, I was just trying to think of something that can actually breach one of these. And it's just a kind of a joke aside. But so I guess my other question is I think a lot of people, maybe they haven't stated it. I don't know how to say that, but they haven't stated it real clearly. But I think a lot of people are afraid that, let's say something bad does happen and there is a nuclear leak, and I think they're afraid that the whole town's going to have to be evacuated.
Mm-hmm.
And I mean, is that a real possibility?
Dead zone.
Like, it become like a dead zone, like Chernobyl. I think that's what a lot of people think about is like Chernobyl. I know Chernobyl was a really terrible accident, and you have to really amp up the danger level to even get close to that. So, I mean, I know that's kind of maybe out of your wheelhouse, but I mean, I'm just trying to spitball ideas here and questions.
Yeah, the only nuclear accidents. Yeah, the only nuclear accidents I'm aware of that involved any kind of evacuation like that was Chernobyl, as you mentioned, and that was a very particular reactor design that did not have a containment building, and none of the reactors currently operating in the U.S. have that design. It was a little bit of a budget reactor design, and there's a reason the U.S. and other countries design different reactors that have containment.
Right.
So that kind of thing wouldn't occur. And then also the Fukushima tsunami and the impacts on the Fukushima Daiichi reactor, which did result in radioactive contamination. And they did have to evacuate the town. Those, I'd say, are both fairly unprecedented events. So it would be very unlikely to have something like that happen in the US, in part because of the safety record that we have with the nuclear industry and the regulatory structure.
Awesome. Do you have anything? I'm just trying to kind of spitball some questions here since I have an expert, and in your opinion, how safe is nuclear storage? Like, one being really, really safe, like super safe, and 10 being, dangerous, as in people are going to die from it. Yeah. Threat to life.
In the US, under the current regulatory structure, I'd say it's at a 1. We have spent nuclear fuel stored all around the country at more than 74 sites. And, it's in pools, it's in dry storage, and there's never been a serious safety issue. I've walked on pads where spent nuclear fuel is stored. I've stood next to them. I've had my photo taken. I've touched them. Never, there are safety precautions. Some, at some of these sites I've been to, you have a dosimeter measuring the radiological dose that you get. And at the end, it's 0.002 or something very low. So there are, because there are all these safety measures in place, it is very safe in the US.
Okay.
And those places you've been to, is that spent fuel from like a reactor?
Yeah,
Facilities,
that's all
so-
spent fuel. That's all nuclear power plants. So I've been to probably about 22 nuclear power plant sites that have either operating or shut down that have spent nuclear fuel stored outside, and walked on several of them. I actually had a photo of several of us with our hands on the cast, but it just didn't fit in the slides I had for this presentation. But maybe
So
I'll roll that out next time.
How does that fuel compare to fuel from this project that is looking at our neighboring area of micro reactors in portable generators, the spent fuel from those? How does that spent fuel compare to, say, the spent fuel from an actual nuclear power plant? Is it
So-
apples to apples and just the quantitative amount is different? Or you spoke earlier about low level, mid level, high level?
Yeah,
spent
it would still
fuel.
be considered high level. Pretty much any material that's being used to power a nuclear reactor would be considered high level nuclear material. I don't know the details of the project. I understand it's Radiant and they plan to manufacture microreactors and do some refueling there. I don't know the detailed specifics of the type of fuel that they plan to use. A lot of the microreactors I'm aware of plan to use something called TRISO fuel, which is like a round particle. So instead of looking like the fuel rods and assemblies that I showed you, it's the TRISO fuel can be in more of a ball with the fuel in the middle and then graphite around it. And it's generally a very stable form of fuel because microreactors are designed for transport. In order to be able to transport them with the fuel inside, you need the fuel to be very stable during transport. So there's a number of different designs out there. The Department of Defense has a microreactor project called Project Pele that's using TRISO fuel. Westinghouse and other companies, many companies right now have designs for microreactors, and the majority of them that I'm aware of are using something called TRISO fuel. Our office, one of my staff has led a group of technical experts to look into some of these advanced reactor or microreactor fuels to understand what the spent fuel is going to look like and how that will fit into our planned system of storage, transportation, and disposal. And right now for the TRISO fuels from microreactors, there's no safety issue with storage and transportation. The question that's a little bit come up is just volume, because the structure of the fuel that has generally graphite on the outside. Again, I don't know if that's specific to the Radiant fuel, but some of the TRISO fuels have sort of a graphite layer around them that just creates a larger volume of fuel, and we might want to look at whether we remove the graphite before we dispose of it to reduce the volume. But in terms of, that's not a safety issue, that's more of an operations and engineering issue. So from a safety perspective, we specifically looked at the safety of storage and transportation, and we have no issues on the safety of storing and transporting that fuel.
Cool. I have one last question and then I think I'm done. So if Radiant, let's say Radiant gets 10 years into their operation and for whatever reason they go bankrupt, and I know that they're supposed to be bonded and insured so that, in case of that happening, that the town is still taken care of and the local, they still take care of their part of the deal of the spent fuel. But what happens over the long term? Who takes control of that radioactive waste and what will happen with it?
Sure. So under the Nuclear Waste Policy Act, that was passed in 1982 and subsequently amended, commercial reactors are required to enter into a contract with the Department of Energy for the department to accept their spent nuclear fuel for disposal. So in the event, and I'm not a lawyer, and, manufacturing microreactors is something that probably wasn't conceived of in the Nuclear Waste Policy Act of 1982 framework. So there's probably some new details to be worked out. But if there is a contract with the department for the department to take ownership and disposal of that spent nuclear fuel, then assuming, nothing unforeseen is part of that situation, then my expectation would be that the department would fulfill the terms under the contract, and take ownership of that material and eventually dispose of it.
Where would you dispose of it at?
Oh, that's a fun question. So the plan for our program, and my colleague Marla Morales is on this call. She's leading both our siting and our disposal activities. We're currently working right now to site a storage facility to allow the government to begin accepting the spent nuclear fuel, and then plan to subsequently follow that with siting a location for a deep geologic repository. You might be aware that there was a previous Yucca Mountain project in Nevada that was originally selected to be the site for final disposal of spent nuclear fuel. For various reasons, that site has been determined to be unworkable. And so we would like to go find another location where a final disposal facility could be built and operated. And that's where spent nuclear fuel from nuclear power plants, as well as from the Navy's spent nuclear fuel and high-level waste from other defense-related activities would all be disposed of potentially. So there is no disposal facility currently, but under the Nuclear Waste Policy Act, the Department of Energy has the obligation to site and manage that disposal facility, and we're very eager to do that.
Right. And so, I mean, currently it would just stay on site, I suppose?
Yes,
Okay.
it would stay on site. We are siting a storage facility that we hope to bring online in the next decade or so. And so it's possible that some of the fuel from around the country could be relocated to that storage facility until a disposal facility is available. But again, that depends on a number of factors, because there are contracts in place that kind of set the order of operations and what fuel moves when.
Awesome. Cool. I don't think I have anything. I'm pretty questioned out. Anything from you, gentlemen?
You're good.
Well, awesome. Well, thank you so much for being here and taking the time to present to the council and to the community. We really appreciate the time and energy you put into this, and to come and kind of educate us and help us, learn about the whole process of spent fuel. So thank you.
Thank you.
Yeah,
thank you.
absolutely. Thanks so much for the invitation. Thanks for your questions. This was all pretty high level. So if more questions come up down the road, or you want to hear more about Marla's work in siting and disposal, happy to come back and answer more questions.
Awesome. Thank you.